Reasoning and proof. Objectives: to use inductive reasoning to make conjectures. Introduction. Inductive reasoning is a reasoning based on patterns you observe. Example 1. It says, what are the next two terms in each sequence? So on the first term, we'll notice we have 45, 40, 35, 30. And if you'll notice the pattern, it looks like we are going down or subtracting 5 each time. So if I'm subtracting 5 each time, I'm going to subtract 5 again, and I will get 25. And then I'm going to subtract 5 again, and I'll get 20. So there are the next two terms on that one. Now on B, we'll notice that it appears that they're taking the midpoints of the sides of the previous figure and connecting them. And notice we have midpoints again here. So we're going to start off, and I'm going to come over here so I have plenty of room. You'll want to make sure you draw this fairly large because it does get a little bit detailed. So there was the first one. This got us to the second term. This got us to the third term, and now we're to the fourth term. Okay, so there's the next one, but we need the next two, so I'm going to draw a big square-like shape. So there's first term, second term, third term, fourth term, and now we're going to add in for our fifth term. So notice what we added was this part here on the fourth term and this part here on the fifth term. Example 2. A conjecture is a conclusion you reach by using inductive reasoning. Example 2, it says, using inductive reasoning, what conjecture can you make about the 21st term in RWB, RWB? Now notice, it's repeating the pattern RWB, RWB. So that means that this is our 1, 2, 3, 4, 5, 6. So I'm going to have RWB. 7, 8, 9, RWB, 10, 11, 12, RWB, 13, 14, 15, RWB, 16, 17, 18, RWB, 19, 20, 21. So our 21st term is B. Example 3, it says, what conjecture can you make about the sum of the first 30 odd numbers? Well, first we need to list the odd numbers. I have 1, 3, 5, 7, 9, 11, 13, 15, blah, blah, blah. It keeps going. Okay, now I don't want to have to find the first 30 odd numbers and type them in my calculator and get a number. That could be tedious, and I could make one small mistake and it would make it incorrect. So I'm going to make a table. So number of odds and their sum. So when I have the first two odd numbers, that's 1 plus 3, and I get 4. When I have 3 odd numbers, I have 1 plus 3 is 4, plus 5 is 9. When I have the first 4 odd numbers, 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. When I have the first 5 odd numbers, I have 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9 is 25. And the first 6 odd numbers, let's see, I was already to 9, so I'm going to add 11, I end up with 36. Now, let's see if we can find a pattern so that way I don't have to add up the first 30 odd numbers, because already at 6 it was taking a little bit of time. You need to ask yourself, when I have this in a column, you can think of this is my x value, this is my y value. What did I do to my x value to get my y value? Well, what do we do to 2 to get to 4? Well, you could say we could multiply it times 2. Well, but 3 times 2 isn't 9. Okay, so does anyone see a pattern in this column? Some of you are noticing, okay, wait, this one I add 5, I add 7, I added 9, I added 11. And some of you are sitting there going, we know that, Dr. Edwards, because that's what we did to get the next number. But watch this. If you look at these, I have another pattern. To go from 5 to 7, I add 2. From 7 to 9, I'm adding 2. And from 9 to 11, I'm adding 2. Whenever your pattern takes 2 steps to go out so that it starts repeating itself over and over again, that usually indicates that you have a squared value. So with that in mind, what do you do to 2 to get to 4? Well, we know that 2 squared is 4. 3 squared is 9. Let's see if the pattern holds. 4 squared is 16. 5 squared is 25. And 6 squared is 36. There's my pattern. So now if I want the sum of the first 30 odd numbers, I'm going to take 30 squared and get 900. Example 4 says, what conjecture can you make about backpack sales in June? Okay, well, if we draw a line of best fit here, let's see, relatively. Let's see, we have November, December, January, February, March, April, May. So right here would be June. June kind of indicates that it's on the decline. They're not selling very many backpacks. So it says, what conjecture can you make about backpack sales in June? Little to no sales. Okay, then it says, is it reasonable to use this graph to make conjecture about sales in August? Explain. Well, if we look at it for sales in August, if we keep going with this trend line, that would say that they're not selling any backpacks in August. Do you think retailers are not selling any backpacks in August? Well, your answer should have been a mental no, because what happens in August? We all go back to school, and we're buying backpacks. So back to school, school buying. Back to school. Increase in backpack sales. So sometimes conjectures, even though they work, they don't work long term. Oh, I missed. A counterexample is an example that shows that a conjecture is incorrect. That would be like the August backpack sales. Okay, on the next one it says, what is a counterexample for each conjecture? It says, if a flower is red, it is a rose. Now, I'll be honest, when I thought of this, the only flower I could think of was a carnation. So I Googled it. You could have a carnation. You could have orchids. You can, by the way, you can Google red flowers. You could have red daisies. All those are counterexamples to if a flower is red, it's a rose. B says one and only one plane exists through any 3 points. Well, if you remember from chapter 1, we talked about where the floor and the wall meet, there was a line, and as long as the points are collinear, they could have more than one plane going through them. They could actually have infinite many planes going through them. So we want to say that if the points are collinear, oh, that looks ugly. Hold on. There are infinite many planes. And just for your reminder, intersection of the floor and the wall. C says when you multiply a number by 3, the product is divisible by 6. Okay, well I'm going to take the number 3 and I'm going to multiply it by 3. I get 9. Is 9 divisible by 6? No, so there is my counterexample. Okay, lesson check. You need to attempt this first before you come to class so that way we can go over it together in class before you start your Math Excel.